So this video is going to look at what we mean by the terms probability, significance, and also type 1 and type 2 errors. And this can be quite a tricky area, and people start to get lost when it goes into type 1, type 2 errors, probability, and you start throwing a few data numbers around. But really stick with it. If there's anything you're unclear of, you just need to rewind the video, try and watch it again to get your head around it. So when we look at your specification, it talks about needing to know about probability and significance and the use of statistical tables and critical values in interpretation of significance. So what we're going to cover in this video is just what probability and significance means. There's a separate video looking at statistical tables and critical values. And we are also going to have a look in this video at type 1 and type 2 errors and what they actually mean. So we're going to have a look at what probability is. Probability is a numerical measure of the likelihood of something actually occurring. And in psychology, we have an accepted level of probability, which is 0.05. And you should remember this from the sign test when we did it in AS. And you might see this sign coming up a lot, P equals or P equals or less than 0.05. And what that means is that the likelihood that the results occur due to chance or luck is equal to or less than 5%. Okay, so when you see that sign, it just means that the likelihood the results were down to chance is only 5%. So in other words, we can be 95% certain that our results were down to changes in the independent variable. So you've got to think, we can never be 100% certain of our results in psychology because we can't test every single person in the world. But by using this statistical measure, we can be 95% certain. And that's pretty good. So again, this P less than 0.05 value, we're just going to run through one more time about what it means. So it means that this is the probability that the difference in your results was caused by chance is less than 5%. So when we've got our results at the end of a study, if we can pass this test, then it means that we can reject the null hypothesis. It means that we are 95% certain of our results. Not only there's a 5% likelihood that the results were down to chance or luck or something else. Okay, so whenever you see that sign, just think, you can be 95% certain of the results, there's a 5% chance that the results were just down to luck. So there are also different p-values that can be used, and you might see some of these pop up in your exam. So we've got P equals 0.01, and this is a very strict measure now. This is, if we pass this test, it means that there's only a 1% likelihood that the results are down to chance. This is a really strict test and really hard for most data to pass. We also got P equals 0.10. So this is a bit of an easier test to pass, and it means that you can only be 90% certain of your results because there's a 10% chance now that the results may have been down to chance. So this first one here, you can be 99% certain of your results. There's only a 1% chance that the results were down to luck. On the other hand, it's very, very strict and hard to pass. And this one here, you can be 90% certain of the results, that the results were down to changes in your independent variable. But on the other hand, there is a 10% chance that the results may just have been down to luck. So when we're using this P 0.01, this is, remember that there's only a 1% chance that the results were down to luck or chance or anything else. It's a very, very, very strict test. And if you pass this test, then you reject the null hypothesis and you can state that your results are highly significant. And that's an important thing here. If you pass this test, the results are highly significant. So the other term, significance, is basically the level of probability at which it's been agreed to reject the null hypothesis. So that number that you see, 0.05, 0.01, 0.1, is the significance. Okay, that's the level at which we agreed to reject the null hypothesis. And this is where we can say, if it does pass this test, then we can say our results are significant, that there is a significant difference when we change the independent variable. So So now we move on to type 1 and type 2 errors. This is where it can get a little bit confusing. So type 1 errors. This is where we reject the null hypothesis that is actually true. So remember, type 1 error, we reject the null when it's actually true. So this usually happens when the significant levels are too high. So we're using that P 0.1, 10% down to chance. Okay. So we claim to find a significant difference. We've conducted our study, we put it through the statistical data tests, and we claim that there is a significant difference in our results, when in fact one doesn't actually exist. It's just this p-test, this one here, is so easy to pass that it's showing there's a significant difference when in fact there isn't. So we're rejecting our null hypothesis. Remember, the null hypothesis will say there is no difference. So we're rejecting the null, we're saying there is a difference, when in fact the null hypothesis was correct. There wasn't a difference at all. A type 2 error, on the other hand, is when we accept the null hypothesis that is in fact false. So remember, the null hypothesis says there will be no relationship. And type 2 errors occur when the significant level is too low. So when we use that p equals 0.01, so we're using that really strict test. And this is a really strict test, so a lot of results that go through it don't actually show a significant difference, even when one does exist. So because it's such a strict test, and basically we've got to be 99% certain of our results, that we put our results through this test, and it always shows, or will mostly show, that there's no significant difference between your conditions, because you've got to be 99% certain. So what we do is, it shows there's no relationship, so we accept the null. We accept that null hypothesis. But in fact, there is a significant difference. But because this test is so strict, that result doesn't come through in the data. Okay? So we claim to find no significant difference when in fact one does exist. So hopefully, if I run through an example with you, it might try and clarify this for you. So we're going to do an experiment looking at whether alcohol affects memory or not. Remember, null hypothesis always says there's going to be no effect. So alcohol will have no effect on the number of words a person can recall in 30 seconds. That's our null hypothesis. So we conduct our study, we analyse all our data, and if we use this significance level here, this P 0.10, then we're going to potentially get a type 1 error. This is where we're going to reject the null hypothesis. So remember, the null hypothesis says it will not have an effect. So we're going to say alcohol does have an effect. Okay, it does affect your memory. However, this statistical test, this significance value, is so easy to pass that most times it's going to show you that there is a significant difference between your conditions. So you always get a type 1 error when you're using this P 0.10. Because it's such an easy test to pass, they will usually show there is a significant difference between the conditions in your experiment. On the other hand, we might get a type 2 error if we're using this far stricter test, this P equals 0.01. So in this case, we're going to accept the null. So we're going to say, right, we're going to claim that the alcohol does not influence your memory whatsoever. But the only reason we're accepting the null hypothesis is because this is such a strict test to pass. So most times it's going to show that there is no significant difference. Okay, so remember, type 1 errors when we're using P equals 0.1, because it's an easy test to pass. Type 2 errors, we usually accept the null hypothesis. We say there's no relationship or there's no difference whatsoever because it's such a strict test to pass. So how do we prevent type 1 and type 2 errors? Well, you know we get type 1 errors when we use an easy test. We get type 2 errors when we use a test that's too hard. So we use P 0.05. And that is the accepted level that psychologists and scientists will use in their studies because it prevents type 1 and type 2 errors from occurring. So you might be asked in an exam about what is the chance of a type 1 or type 2 error actually occurring. And it depends on the p-value being used in the study. So if we're using p equals 0.05, then the chance of any error occurring is 5%. Okay, so think about it like this. If the level of significance is set at 5%, like we've got here, set at 5%, then there will always be a 1 in 20 chance, or 5% chance, that the results were down to chance, rather than influencing the independent variable. So the results could always be down to something else. When we're using p equals 0.01, there's only a 1% chance. Okay, this is a very strict test. You're 99% certain of your results. So there's only leaving 1% chance of a type 1 or type 2 error occurring. And the same occurs if we use p equals 0.10. There's now 90% certain of your results. So there's a 10% chance of a type 1 or type 2 error occurring.